June 12, 1943. Capoterra Airfield, Sardinia. Lieutenant Colonel Angelo Tondi of the Regia Aeronautica climbed from the cockpit of the captured Lockheed P-38G Lightning he had just landed. The American fighter had arrived on Italian soil through navigation error, its pilot disoriented after a compass failure over the Mediterranean. Within hours, this intact example of America's most feared twin-engine fighter would be examined by Axis engineers, including Japanese technical observers stationed in Italy. What they would discover would fundamentally challenge their understanding of fighter aircraft design philosophy. The twin Allison engines that had brought the aircraft safely to Earth despite battle damage and mechanical stress represented more than redundant power. They embodied an entire approach to aerial warfare that stood in stark contrast to the single-engine philosophy dominating Japanese fighter design. Over the following months, as Japanese pilots encountered P-38 seconds with increasing frequency across the Pacific, the tactical implications of that second engine would become devastatingly clear. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. American pilots were flying home on one engine with damage that would have doomed any Zero, any Oscar, any fighter in the Japanese inventory. The path to Tondi's examination began in February 1937, when the United States Army Air Corps issued Circular Proposal X 608. First Lieutenants Benjamin Kelsey and Gordon Saville authored performance goals that seemed nearly impossible to achieve. The specification called for a twin-engined, high-altitude interceptor, capable of reaching 360 miles per hour at 20,000 feet, able to climb to that altitude in 6 minutes, and possessing tactical mission capability for interception and attack of hostile aircraft at extreme altitude. Lockheed Corporation had never built a military fighter. The firm's chief engineer, Hall Hibbard, and his young assistant, Clarence Kelly Johnson, studied the requirements. No American engine then in production generated sufficient power to meet the specifications in a single-engine configuration. The solution required 2 engines, but integrating twin engines into a fighter design presented challenges no American manufacturer had successfully solved. Johnson's team developed a revolutionary configuration. Rather than a traditional fuselage, the P-38 would feature 2 engine nacelles extending rearward from mid-wing positions into elongated tail booms. These booms would house the turbo superchargers and connect at the tail via horizontal stabilizers mounting twin rudders. The pilot would sit in a central nacelle positioned between the engines, with all armament concentrated in the nose. 4 50-caliber machine guns and 1 20mm cannon would fire directly forward along the aircraft's centerline, eliminating the convergence problems inherent in wing-mounted guns. The configuration offered unexpected advantages. With engines separated by the width of the wing, propeller rotation could be arranged so that each engine counteracted the torque of the other. Standard fighters with single engines suffered from pronounced leftward yaw during takeoff and climb. The P-38's counter-rotating propellers, spinning outward at their tops, eliminated this tendency. The nose-mounted armament provided accuracy impossible with wing guns. Bullets from all weapons converged perfectly from launch, creating a cone of fire deadly out to 1,000 yards. On January 27, 1939, Lieutenant Kelsey flew the XP-38 prototype for the first time. 11 days later, attempting a transcontinental speed record, Kelsey crashed the prototype at Mitchell Field, New York, due to carburetor icing during his approach. He survived. The Army ordered 13 YP-38 service test aircraft on April 27, despite losing the prototype. The Japanese Navy's carrier striking force attacked Pearl Harbor on December 7, 1941. Within hours, the Army Air Forces commandeered 40 P-38 seconds, awaiting delivery to Britain at Lockheed's Burbank plant. These aircraft, still bearing Royal Air Force markings, were distributed to West Coast bases. The United States had precisely 69 P-38 seconds in service on the day war began. The first P-38 seconds to reach Pacific combat arrived on April 4, 1942, when F-4 photo reconnaissance Lightnings joined the 8th Photographic Squadron in Australia. These unarmed variants carried cameras in place of weapons, conducting reconnaissance missions over New Guinea and New Britain. By May 29th, 25 P-38Es had arrived in Anchorage, Alaska, assigned to defend the Aleutian Islands chain. On August 9th, 1942, two P-38Es of the 343rd Fighter Group encountered two Japanese Kawanishi H-6K flying boats near the end of a 1,000-mile patrol. Lieutenants Kenneth Ambrose and Stanley, long attacked. Both Japanese aircraft fell into the sea. The Lightning had recorded its first aerial victories. In the southwest Pacific, P-38 seconds began arriving at Port Moresby, New Guinea. In November 1942, the 39th Fighter Squadron of the 35th Fighter Group received the type first. Their combat debut came on December 27th, when Lightning pilots claimed 11 Japanese aircraft destroyed for the loss of one P-38F. Among the victorious pilots was Second Lieutenant Richard Bong, credited with 2 kills. He would eventually destroy 40 Japanese aircraft, all while flying P-38 seconds, becoming America's highest-scoring ace. The Japanese had encountered nothing like the P-38. Their frontline fighters, the Mitsubishi A-6M0 and the Nakajima Ki-43 Oscar, represented a design philosophy centered on extreme maneuverability and light weight. Japanese engineers had sacrificed armor protection, self-sealing fuel tanks, and heavy armament to achieve turn. Performance superior to any Allied fighter, a Zero could execute a complete horizontal turn in roughly half the time required by a P-38. In close combat below 200 miles per hour, the Zero held overwhelming advantages. But the P-38 did not fight the Zero's fight. American pilots quickly learned the tactical implications of their aircraft's strengths. The Lightning could reach 400 miles per hour in level flight, 100 miles per hour faster than the Zero. Its turbo-supercharged engines maintained full power to altitudes where Japanese fighters gasped for air. Its rate of climb allowed vertical maneuvers impossible for lighter aircraft. Its concentrated armament delivered devastating firepower. The correct tactic became clear. Remain at altitude, dive at high speed, fire a brief, accurate burst, then climb back to safety using superior power and speed. Never attempt to turn with a Zero. Never slow down. Never allow the fight to devolve into a low-speed, turning, dogfight. Use energy, use altitude, use speed. Disengage whenever the situation deteriorated. Japanese pilots began reporting encounters that defied their combat experience. P-38 seconds would appear at 25,000 feet, well above the effective ceiling of most Japanese fighters. They would dive with shocking speed, their nose-mounted guns creating a stream of fire that required no lead time, no compensation for convergence. The attack would last seconds. Before Japanese pilots could react, the P-38 seconds would be climbing away, using power that no Japanese engine could match. Attempts to pursue proved futile. The Americans simply climbed higher and faster, reaching altitudes where Japanese aircraft struggled to maintain level flight. More troubling were reports of damaged P-38 seconds escaping combat. Japanese pilots would score hits, see smoke trail from an engine, watch as the American fighter lost power and altitude. Victory seemed certain. Then the P-38 would level off and continue flying. One engine had failed, but the second kept the aircraft airborne. The American would turn toward friendly bases, limping home on half his power. Japanese pilots could do nothing but watch their wounded opponent escape. This phenomenon became increasingly common as the air war intensified. A Zero pilot who damaged an enemy aircraft expected that damage to be fatal. Japanese fighters carried minimal ammunition and flew without armor protection, specifically to maximize maneuverability. When they scored hits, those hits had to count. A burning engine meant certain death, a crash into the jungle or sea. But P-38 seconds refused to die. They absorbed damage that would have destroyed any Japanese fighter and kept flying. The captured P-38G that Lieutenant Colonel Tondi flew to Guidonia Airfield near Rome in mid-June. 1943 provided Japanese technical observers their first opportunity to examine the Lightning systems in detail. Engineers from the Koku, Gijutsu, Kenkyujo, The Imperial, Japanese Navy's Air Technical Research Institute, had been stationed in Europe since 1941 to study German and Italian aircraft development. News of an intact American twin-engine fighter triggered immediate interest. The examination began with the engines. Each Allison V-1710 liquid-cooled engine generated 1,325 horsepower at 25,000 feet, maintaining power through turbo-supercharging. Japanese engineers noted the complexity of the installation. Each engine drove not only its propeller, but also powered an independent electrical system, hydraulic system, and set of flight controls. The systems were designed with complete redundancy. If one engine failed, the other could operate all critical aircraft systems. The fuel system revealed sophisticated engineering. The P-38G carried 300-gallon capacity in sealed tanks, with additional drop tanks extending range beyond 1,500 miles. But more significant than capacity was management. The fuel system allowed precise control over which tanks fed which engines, enabling pilots to balance the aircraft perfectly, even with one engine dead. Transfer pumps could move fuel between tanks. Emergency systems provided backup feeding methods. The entire installation reflected an assumption that single-engine operation was not only possible, but expected. The flight control systems demonstrated the same philosophy. Dual hydraulic systems operated independently. If one system failed, the other maintained full control authority. Trim tabs could be adjusted to compensate for asymmetric thrust. Rudder authority was sufficient to counter the yaw produced by single-engine flight. The massive vertical stabilizers provided directional stability that made single-engine flight manageable for pilots of moderate skill. Most striking was the structural philosophy. The P-38's airframe weighed significantly more than any Japanese fighter. The Zero's empty weight was approximately 4,100 pounds. The P-38G weighed nearly 12,400 pounds empty. That additional weight brought structural strength, armor protection, and systems redundancy that Japanese engineers had deliberately sacrificed. Japanese technical observers compiled detailed reports and forwarded them to Tokyo. The conclusions proved sobering. The P-38 represented a fundamentally different approach to fighter design, where Japanese fighters optimized for the perfect fight, a close-range turning engagement where pilot skill and aircraft maneuverability determined victory. The P-38 optimized for imperfect combat. It assumed pilots would be shot, engines would fail, systems would be damaged. It built in margins for error, redundancy for survival, power for escape. By late 1943, Japanese pilots throughout the Pacific had learned to recognize the P-38's silhouette. The distinctive twin booms and wide-set engines made identification easy. Intelligence reports warned pilots to avoid prolonged combat with the Lightning. The aircraft's diving speed approached compressibility limits, making it nearly impossible to follow in a dive. Its climbing performance at high altitude exceeded anything Japanese fighters could achieve. Its concentrated firepower could destroy aircraft with brief bursts. And its twin engines meant that damaged P-38 seconds would escape, surviving hits that should have been fatal. The psychological impact proved as significant as the tactical challenge. Japanese pilots had entered the war confident in their superiority. The Zero's dominance in 1941 and early 1942 had seemed to confirm Japanese fighter design philosophy. Lightweight, extreme maneuverability, and skilled pilots would overcome any opponent. But the P-38 invalidated those assumptions. American pilots flying inferior aircraft in terms of pure maneuverability were winning through superior speed, altitude, performance, and survivability. The twin-engine configuration that Japanese engineers had examined in Italy manifested its advantages across thousands of Pacific combat missions. P-38 pilot after P-38 pilot returned to base after engine failures, battle damage, mechanical problems that would have killed pilots in single-engine fighters. The statistics accumulated slowly but inexorably. Abort rates due to engine failure were higher for P-38 seconds than for single-engine types, but mission completion rates remained comparable because P-38 pilots could continue missions on one engine or return safely to base after losing power. General George Kenney, commander of the 5th Air Force in the Southwest Pacific, repeatedly requested more P-38 seconds. In conversations with General Henry Arnold, Army Air Forces Commanding General, Kenny explained his reasoning with brutal clarity. He valued the P-38 not because it was the best pure fighter, but because it brought pilots home. Missions over the Pacific meant flights of hundreds of miles over, open ocean or impenetrable jungle. In a single-engine fighter, engine failure meant death or capture. In a P-38, engine failure meant a difficult but survivable flight home. Kenny later explained his logic in terms of pilot effectiveness. A P-51 Mustang might be a superior aircraft by pure performance metrics, rating perhaps 100 points, but a P-51 pilot flying 400 miles over ocean would arrive at the combat zone with morale degraded by stress, performing at perhaps 50% effectiveness. Total combat value, 150 points. The P-38 might rate only 75 points as a pure fighter, but its pilot would arrive at 100% effectiveness because he knew that second engine could bring him home. Total combat value, 175 points. The psychological advantage of redundancy exceeded any performance deficit. The most dramatic demonstration of the P-38's single-engine capability came on April 18, 1943. Navy codebreakers had intercepted and decrypted Japanese communications detailing Admiral Isoroku Yamamoto's inspection tour of forward bases in the Solomon Islands. Yamamoto had planned the Pearl Harbor attack and commanded the combined fleet. His loss would devastate Japanese naval operations and morale. The mission required a round-trip flight of nearly 1,000 miles, most over open water, to intercept Yamamoto's transport aircraft near Bougainville Island. No American fighter except the P-38 possessed sufficient range. 16 P-38Gs from the 339th Fighter Squadron launched from Guadalcanal. The route required precise navigation, careful fuel management, and the assumption that some aircraft would experience mechanical problems during the extended flight. During the transit, 2 P-38 seconds discovered their drop tanks would not release. Unable to maneuver effectively with the extra weight and drag, both pilots had to abort. 14 Lightnings continued. They located Yamamoto's transport precisely on schedule, despite flying a circuitous route designed to appear coincidental. In the brief combat that followed, P-38 pilots shot down both Japanese transport aircraft. One carried Yamamoto. The admiral died in the crash, found the next day still strapped in his seat. The mission demonstrated capabilities unique to the twin-engine fighter. The range to reach the intercept point exceeded the capability of any contemporary single-engine fighter. The reliability to complete the mission, despite the loss of 2 aircraft to mechanical problems, vindicated the redundancy philosophy. The concentrated firepower delivered by nose-mounted weapons destroyed both targets within seconds, and the speed to disengage and escape pursuing Japanese fighters ensured that American losses remained minimal. By mid-1944, P-38 pilots had developed refined single-engine procedures. If an engine failed in combat, the pilot would immediately trim the aircraft, for level flight using rudder trim and aileron. Power on the functioning engine would be reduced temporarily to minimize yaw, then increased gradually as the aircraft stabilized. The propeller on the failed engine would be feathered, aligning with the airstream to minimize drag. With careful power management, a P-38 could maintain altitude and even execute gentle turns on a single engine. Training emphasized single-engine flight. Pilots practiced asymmetric takeoffs and landings. They learned the aircraft's single-engine performance envelope at various weights and altitudes. They understood that a fully loaded P-38 could not maintain altitude on one engine during takeoff, but once, airborne and climbing, single-engine flight became manageable. The procedures were complex compared to single-engine emergency protocols, but they were achievable. Dozens of pilots owed their lives to the training and the aircraft's forgiving single-engine characteristics. The contrast with Japanese fighter experience grew more pronounced as the war progressed. 0 pilots flying from Rabaul to Guadalcanal operated at the extreme limit of their range. They arrived at the combat zone with minimal fuel reserves. If their single engine showed any sign of trouble, if combat damage affected fuel tanks or oil lines, if carburetor icing or mechanical failure reduced power, Death was nearly certain. They could not reach friendly territory on partial power. They had no backup systems, no redundancy, no safety margin. American intelligence officers interrogating captured Japanese pilots documented this psychological burden. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Japanese aviators spoke of constant anxiety during long over-water flights. The sound of the engine became an obsession. Any change in pitch, any vibration, any indication of mechanical stress triggered fear. They flew knowing that mechanical failure meant ditching in the ocean, likely death from drowning or shark attack. The stress accumulated over missions, eroding effectiveness and morale. P-38 pilots, flying the same routes, experienced different psychology. Engine reliability was never perfect. Mechanical failures occurred regularly, but when an engine failed, it was a problem, not a death sentence. The pilot would secure the dead engine, adjust power and trim, and continue the mission or return to base. Dozens of pilots experienced engine failures and lived to fly again. The confidence that survival was possible despite mechanical failure reduced stress and allowed pilots to focus on combat effectiveness rather than mechanical anxiety. The Japanese response to the P-38's twin-engine advantage revealed the constraints of their industrial capacity. Engineers understood the value of redundancy. Technical reports from Europe had documented the P-38's survivability, but implementing similar designs proved impossible. Japan's aluminum production was insufficient to build heavier airframes. Engine production could barely meet demands for existing single-engine types. Training programs could not prepare pilots for complex twin-engine procedures. The industrial and technical infrastructure required for twin-engine fighter production at scale exceeded Japan's capabilities. Japanese attempts to develop twin-engine fighters produced limited results. The Kawasaki Ki-45 Toryu served as a heavy fighter and night fighter, but lacked the performance to challenge enemy single-engine fighters. The Nakajima J-1N Gecko functioned adequately as a night fighter, but was hopelessly outmatched in daylight combat. The Mitsubishi Ki-83, which might have rivaled the P-38's performance, never entered production before the war ended. Japan's fighter force remained dominated by single-engine types throughout the conflict. By late 1944 and into 1945, the disparity in fighter philosophy had become undeniable. P-38 pilots routinely completed missions that Japanese pilots would have considered impossible. Flights lasting 10 hours covered distances exceeding 3,000 miles. Combat damage that would have doomed Japanese aircraft resulted in P-38 seconds, limping home on partial power. The accumulated survival rate advantage compounded over thousands of missions and hundreds of pilots. The statistical evidence supported the operational observations. P-38 units in the Pacific achieved higher pilot survival rates than comparable single-engine units, despite flying equally dangerous missions. When aircraft were damaged or disabled, P-38 pilots had meaningful survival options. They could attempt to reach friendly territory on one engine, ditch closer to rescue assets, or maintain altitude long enough to reach areas where rescue was feasible. Single-engine fighter pilots had no such options. Engine failure or critical damage meant immediate loss of altitude and forced landing in hostile territory or water. The legacy of Lindbergh's fuel management techniques, taught to Satan's Angels pilots in mid-1944, further extended the P-38's already substantial advantages. By carefully managing engine parameters and fuel consumption, pilots extended combat radius by hundreds of miles. The combination of extended range and twin-engine reliability created operational flexibility that Japanese forces could not counter. P-38 seconds could reach targets previously considered beyond fighter escort range. They could loiter over combat zones longer than Japanese aircraft could remain airborne. They could absorb battle damage and continue operations. The human cost of the single-engine versus twin-engine philosophy manifested in survival statistics. Japanese pilot losses mounted throughout 1943 and 1944. Experienced aviators died in circumstances where P-38 pilots would have survived. Engine failures during long-range missions killed pilots who had survived combat unscathed. Battle damage that American pilots considered survivable proved fatal to Japanese pilots, lacking redundant systems and backup engines. By the war's final year, the psychological advantage had shifted decisively. P-38 pilots flew with confidence born of survivability. They knew the aircraft would bring them home even after mechanical failure or battle damage. Japanese pilots flew knowing that any significant problem meant death. The stress differential affected combat effectiveness. Confident pilots flew more aggressively, took calculated risks, pressed attacks. Stressed pilots flew conservatively, disengaged early, avoided situations where mechanical failure might prove fatal. The principle that Japanese observers had first documented in Italy in 1943 had proven decisive across 2 years of Pacific combat. Twin engines meant American pilots flew home on one engine. That simple advantage, multiplied across thousands of missions and hundreds of pilots, had saved lives, maintained experience levels, and sustained combat effectiveness. Japanese pilots, flying excess life, brilliant aircraft optimized for perfect combat conditions, died in situations where American pilots survived. The Lockheed P-38 Lightning flew in combat until the war's final day. Over 10,000 were manufactured, flying more than 130,000 missions. In the Pacific theater, P-38 pilots shot down more Japanese aircraft than pilots flying any other American fighter. 7 of the 8 highest-scoring American aces flew P-38 seconds, led by Richard Bong with 40 victories. The aircraft's combination of range, firepower, speed, and survivability made it the dominant American fighter in the Pacific campaign. But perhaps the Lightning's most important contribution was the one Japanese engineers had first documented while examining the captured P-38G at Guidonia. The twin-engine configuration represented a design philosophy that valued survival over perfection, redundancy over optimization, margin for error over theoretical maximum performance. In the imperfect reality of combat, where engines failed and pilots were wounded and aircraft were damaged, those values proved decisive. The pilots who flew the P-38 inches the Pacific never forgot what the twin engines meant. In interviews conducted decades later, veterans spoke of the comfort provided by that second engine during long over-water flights. They described engine failures that would have killed them in single-engine fighters, but proved manageable in the P-38. They recalled damaged aircraft that brought them home, despite destruction that should have been fatal. The second engine was not just a mechanical system, it was a psychological asset, a survival margin, a reason to believe you might see another sunrise. The Japanese pilots who fought against the P-38 learned the same lesson from the opposite perspective. They watched damaged American fighters escape when Japanese aircraft would have crashed. They experienced the frustration of scoring hits that would have destroyed a Zero but only disabled one engine of a Lightning. They understood that American pilots possessed a survival advantage that no amount of skill or bravery could overcome. The twin engines meant Americans flew home. That simple reality, repeated across thousands of engagements, represented a war-winning advantage. Lieutenant Colonel Angelo Tondi, who had captured the P-38G and flown it to Italian territory, continued flying the aircraft for several weeks. On August 11, 1943, he took off in the Lightning to intercept American bombers returning from a raid on Terni. Tondi attacked a B-17 named Bonnie Sue, shooting it down into the sea near Torvaianica. According to American sources, he damaged 3 additional bombers. On September 4th, the 301st Bombardment Group reported losing B-17 the Lady Evelyn to an enemy P-38. The irony was complete. A captured American fighter, flown by an Italian pilot, attacking American bombers. But the captured P-38's combat career was brief. Italian aviation fuel proved corrosive to the Lightning's tanks, limiting flight operations. When Italy surrendered on September 8, 1943, the aircraft's fate became uncertain. It disappeared from records, likely destroyed by German forces or Italian personnel to prevent its recapture. The lessons learned from examining that captured aircraft survived in Japanese technical reports and intelligence assessments. Those documents circulated throughout Japanese naval aviation, informing tactical recommendations and design philosophies. The recommendations emphasized avoiding combat with P-38 seconds, using altitude and speed against them, never attempting turning fights. But the recommendations could not change the fundamental disadvantage. Japanese fighters remained single-engine aircraft. No tactical adjustment could overcome the survival advantage of redundant power. In the final analysis, the story of the P-38 inches the Pacific represents a triumph of engineering philosophy over pure performance. The Lightning was not the fastest fighter, nor the most maneuverable, nor the best climbing, but it was the most survivable. It brought pilots home after engine failures, after battle damage, after mechanical problems that would have doomed pilots in optimized single-engine fighters. That survival advantage, combined with adequate performance in all flight regimes and excellent armament, made it the most effective American fighter in the Pacific theater. The examination that began at Guidonia Airfield in June 1943 revealed a truth that Japanese aviation could acknowledge, but not overcome. Modern aerial warfare demanded redundancy, survivability, and margin for error. The perfect fighter, optimized for ideal conditions, would lose to the adequate fighter built to survive imperfect reality. The second engine was not a backup system. It was the fundamental difference between flying home and dying in a jungle or drowning in an ocean. American, industrial capacity allowed construction of thousands of twin-engine fighters when most nations could barely produce single-engine types in adequate numbers. American training programs prepared pilots for complex twin-engine procedures when other air forces struggled to provide basic flight instruction. American engineering philosophy prioritized survival when other nations optimized for performance. The combination proved decisive. The P-38 Lightning's legacy extends beyond its combat record. It demonstrated that strategic choices in aircraft design could be as important as tactical performance. It proved that pilot survival and aircraft survivability were combat multipliers as significant as speed or maneuverability. It showed that redundancy and safety margins, often dismissed as conservative or excessive, could be war-winning advantages in sustained combat. And it established that twin-engine fighters could be as agile and effective as single-engine types if designed correctly and flown with appropriate tactics. Japanese pilots who survived the war remembered the P-38 with respect and frustration. They had faced an opponent that refused to fight their fight, that survived damage that would have destroyed their aircraft, that brought American pilots home after engine failures Japanese pilots could not survive. The twin-boom silhouette had come to represent not just a specific aircraft but an entire philosophy of design and combat. American pilots flew home on one engine because American engineers had given them that capability. Japanese pilots died after engine failures because Japanese constraints had denied them redundancy. The story began with a captured aircraft on a Mediterranean airfield and ended with American air supremacy across the Pacific. The technical observers who examined that P-38G in 1943 had understood what they were seeing. They had documented the systems, analyzed the philosophy, recognized the advantages. Their reports had reached Tokyo and circulated throughout Japanese naval aviation. But understanding the problem and solving it were different challenges. Japan lacked the industrial capacity, the technical infrastructure, and the resources to implement twin-engine fighter production at the scale required. Understanding came too late, and without the means to respond. The P-38 Lightning flew its final combat mission on the day Japan surrendered. On August 25, 1945, two P-38 pilots became the first American aviators to land on Japanese soil after the surrender. The symbolism was fitting. The aircraft that had terrified Japanese pilots, that had shot down Yamamoto, that had established American air superiority through superior survivability, touched down on enemy territory as conqueror. The twin engines that had brought so many American pilots home had brought these pilots to victory. The stories of individual survival illustrated the principle with stark clarity. Lieutenant Thomas Lynch of the 39th Fighter Squadron experienced engine failure over the Bismarck Sea in January 1943 while escorting bombers to Rabaul, 500 miles from Port Moresby, 400 miles from any friendly territory, his right engine seized without warning. Oil pressure dropped to 0. Temperature gauges climbed into the red. He secured the failed engine, feathered the propeller, trimmed the aircraft for level flight on single-engine power. The return flight took 3 hours. Lynch maintained altitude at 8,000 feet, managing fuel carefully to ensure the remaining engine received adequate supply. He monitored cylinder head temperatures, adjusted mixture settings, watched for any indication that the second engine might fail. Japanese fighters operating near Rabaul could have intercepted him easily, but he maintained radio silence and altered course to avoid known patrol routes. He landed at Port Moresby, with the damaged engine trailing smoke, and the functional engine running rough from extended high-power operation. Maintenance crews found metal fragments throughout the failed engine. A connecting rod had fractured. In a single-engine fighter, the failure would have been immediately fatal. Lynch returned to combat operations within days. He was killed 2 months later, not by mechanical failure but by anti-aircraft fire while strafing Japanese ships. He had survived long enough to score 21 aerial victories and train dozens of younger pilots. The engine failure that would have killed him in January had been merely an inconvenience, a training opportunity, proof that the system worked as designed. Captain Richard Bong experienced similar events throughout his combat tour. On multiple occasions, he returned to base with one engine damaged or disabled by enemy fire. In March 1944, a Japanese fighter scored hits on his left engine during combat near Hollandia. The engine lost power and began trailing smoke. Bong continued engaging enemy aircraft with his remaining engine and weapons, shooting down 2 Japanese fighters before disengaging. He flew 150 miles back to base on single-engine power, landed without incident, and was flying a different P-38 the next morning. The accumulated experience of hundreds of such incidents transformed pilot attitudes toward long-range over-water missions. In early 1943, before P-38 seconds arrived in significant numbers, pilots flying single-engine P-40 Warhawks and P-39 Airacobras dreaded missions beyond gliding distance of land. The psychological burden of knowing that engine failure meant certain death affected mission planning, tactical decisions, and pilot morale. Commanders had to consider not just the military objective but the psychological cost of sending pilots on extended over-water flights in single-engine aircraft. The P-38's arrival changed the calculation. Pilots still respected the dangers of long-range missions over hostile territory. Engine failures remained serious, emergencies requiring immediate action and careful flying. But the transition from certain death to manageable problem fundamentally altered mission planning. Routes that had been considered suicidal in single-engine fighters became routine in P-38 seconds. Escort missions that would have required elaborate planning for rescue forces could proceed with standard precautions. The operational flexibility gained from twin-engine reliability expanded the tactical possibilities available to commanders. General Kenny exploited this advantage systematically. He assigned P-38 units to the longest range, most dangerous missions, knowing they possessed the best chance of completing objectives and returning safely. When targets required fighter escort beyond the range of single-engine types, P-38 seconds flew the missions. When reconnaissance demanded deep penetration into enemy-held territory, F-4 and F-5 photo reconnaissance Lightnings carried the cameras. When ground attack missions required operation over water or hostile jungle far from friendly bases, P-38 seconds delivered the ordnance. The Japanese response revealed their understanding of the problem and their inability to solve it. Intelligence reports captured later in the war showed that Japanese naval aviation had recognized the P-38's twin-engine advantage as early as mid-1943. Technical assessments accurately described the survival benefits of redundant power plants and backup systems. Tactical recommendations emphasized exploiting the P-38's weaknesses, its relatively large size making it visible at distance, its poor low-speed maneuverability, its tendency toward compressibility problems in high-speed dives. But the recommendations could not address the fundamental disparity. Japanese pilots flying optimal tactics in superior maneuvering aircraft still died when engines failed. They still crashed when battle damage affected their single engine. They still, faced the psychological burden of knowing survival depended entirely on one engine, continuing to function throughout missions that might last 4 or 5 hours over open ocean. No amount of tactical sophistication could overcome that disadvantage. Japanese engineering efforts to develop competitive twin-engine fighters founded on resource constraints and competing priorities. The Kawasaki Ki-45 Toryu had entered service in late 1942 as a heavy fighter and night interceptor. It proved adequate against bombers, but hopelessly outmatched by American single-engine fighters, let alone the P-38. The aircraft's two Mitsubishi Ha-102 engines generated only 950 horsepower each, barely half the power of the P-38's Allisons. Maximum speed reached only 340 miles per hour. Range and climb performance fell well below Lightning standards. The Nakajima J-1N Gecko performed somewhat better as a night fighter, equipped with primitive airborne radar and upward-firing cannon for attacking bombers from below. But daylight operations against fighters proved impossible. The aircraft was too slow, too unmaneuverable, too vulnerable. It survived only by operating at night when American fighters could not locate it visually. The most promising Japanese twin-engine fighter design, the Mitsubishi Ki-83, reached prototype stage in late 1944. Engineers had created an aircraft with performance potentially matching or exceeding the P-38. Maximum speed approached 430 miles per hour. Range exceeded 2,000 miles. Armament included two 30mm cannon and two 20mm cannon. The design incorporated many lessons learned from examining captured American aircraft and combat reports describing P-38 operations. But the Ki-83 never entered production. By late 1944, American bombing had crippled Japanese industrial capacity. Aluminum shortages affected all aircraft production. Engine manufacturing could barely maintain output of existing types. Introducing a new design requiring new tooling, new training, and new logistics proved impossible. 4 prototypes flew. None saw combat. The war ended before production could begin. The story of the Ki-83 encapsulated Japan's predicament. Japanese engineers understood what needed to be done. They possessed the technical knowledge to design competitive aircraft. But understanding and capability were separate things. The industrial base required to manufacture modern twin-engine fighters at scale exceeded Japan's resources by 1944. The war of attrition had been lost not in the air but in the factories, not through tactical failures but through industrial inadequacy. American production, by contrast, overwhelmed all constraints. Lockheed's Burbank plant manufactured P-38 seconds continuously from 1941 through 1945. At peak production in 1944, the factory completed more than 30 Lightnings per day. Total production exceeded 10,000 aircraft. Subcontractors manufactured components in dozens of facilities across the United States. The supply chain supporting P-38 production employed tens of thousands of workers and consumed aluminum, steel, and strategic materials in quantities that would have strained Japan's entire industrial economy. That productive capacity translated directly into combat advantage. When P-38 seconds were lost to enemy action or accidents, replacements arrived within weeks. When pilots needed additional training aircraft, surplus P-38 seconds were available. When new squadrons required equipment, sufficient aircraft existed to outfit entire groups. The abundance eliminated concerns about conservation or careful husbandry of scarce resources. Aircraft could be flown aggressively, risks could be accepted, losses could be sustained, because the industrial base would replace whatever was lost. Japanese forces operated under opposite constraints. Every aircraft was precious. Losses hurt not just immediate combat strength but long-term capability. Replacement aircraft arrived slowly, if at all. Pilot training programs could not maintain pace with attrition. By late 1944, experienced pilots were flying with inexperienced wingmen in insufficient numbers of increasingly obsolescent aircraft. The material imbalance had become insurmountable. The P-38's twin-engine survivability advantage amplified the production disparity. American losses were lower because damaged aircraft returned to base rather than crashing. Pilots survived to fly again rather than dying in forced landings. Experience accumulated in veteran pilots rather than being lost with each engine failure. The compound effect of better survival rates and higher production created an accelerating advantage that Japanese forces could not counter. By 1945, the aerial balance had shifted decisively. American fighters dominated Pacific skies. P-38 seconds ranged freely across territories Japan had conquered years earlier. Japanese fighters appeared in decreasing numbers, flown by increasingly inexperienced pilots, facing opponents who possessed every advantage. The twin engines that had saved so many American pilots in 1943 and 1944 continued saving lives in 1945, but by then the outcome was no longer in doubt. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.